じゃあ、ユニティ早速触っていきましょう。あれあ、サインしてなかった。失礼いたしました。違う。パスワード間違えた。これかな。違う。なんだ。入れない。マジか。違う。違う、間違った。はい。ちょっと待ってくださいね。はいはいはい。パスワード忘れたんでちょっと待ってくださいね。昨日入れたんだけどな。昨日入って今日忘れるんだよな。リセットパスワード。これもしかしてあれか。あれか。クロームに保存されてるかな。見てみよう。ひどい話だぜ。ユニティ。はい。これか。はいはいはいはいと。よし、入った。よかった。よ。はい。よ。ちょっと待って。ライセンスがありませんって言ってきちゃう。なんだこれ。ちょっと待って。ちょっと待って。パーソナル。はい。前年度。はいはい。実行。はい。本当に今日発行できるわけですね。はい、OK です。はいはい。やっと始められる。なんだこの無駄に長い時間は。はい、それではやっていきましょう。お風呂なう。はい、お風呂。ゆっくり入っといて。お風呂なうってことはお風呂で見てんのこれ。大変だね、君もね。あら、いいやん。はい。それじゃあやっていきましょう。ユニティ。ユニティ。ウニウニ。ですね、今回はですね、スキップニューバージョン。はい。アップデート確認いらない。スキップで。はい。今回はですね、Unity の公式ページ、でもないか。前の、何年前かわからないんですけど、私が初めて Unity を触った時に、チュートリアルで私が途中でやめた Unity のチュートリアルが、なんだっけ、ボードの上で、プレーンの上で、これね、これの上で、ボールをこう動かしてポイントを稼ぐってやつだったんですけど、それを今、実装してみようと思います。これ、ロールアボールってやつ。これ。これをね、実装してますと。それね、サインしちゃいましょう。大丈夫だったか。これね、で、今どこまで行ったんだっけな。これ
In this
うるせえ。in this。はい。ちょっとすいません。ちょっと耳が死んだかもしれないですけど、すいません。はい、こちらをやっていきます。ね。何年前か忘れたんですよね。これ。まあ、今となっては別の YouTube チュートリアルがあるのかもしれないですけど、私これが懐かしいんでこれやってます。で、はい。次。これは終わってますね。で、今のところこのボードを設置して、マテリアルを設定して、色をつけて、物理演算して、ここ。そう、これ。ちょっとプログラミングしようぜみたいなノリのやつをやっているところですね。あとフォース、力を加えるって。ここですね。じゃあちょっと開いていきましょう。まずは、このボール自体の、これか。スクリプトの編集自体はVS コードでやっています。使い慣れてるからね。はい。で、今ここまでですね。インプット、ゲット、アクセス、ホライズンとバーティカルで、ホライズンがどっちだっけ高さ、違う、高さじゃない。わかんない。まあ、Z 軸だか Y 軸だか X 軸だか忘れましたけど、それをこう、ゲットアクセスで取得していますと。で、次に、これですね。ベクター、ムーブメント。ちょっとゲットアクセス、ゲットアクセスって現在のあれじゃないの？インプットが、入力があった方がいいですね。入力、縦方向、横方向。まあ、そのどっちかがどっちだと思います。これかな。横型。垂直。なるほど。わかんないけどわかる。はい。まあ、こちらが前、後ろ、ホライゾンが横かなの方向に移動していることを見るみたいな感じだと思います。合ってる？で、これを、ベクターさん。ベクターって、ベクトルの、ベクトルか。ベクターじゃない。ベクターだとなんか敵キャラになっちゃうんですね。ベクトル3ということで、3つの、ベクトル、1、2、3と、3種類のベクトルを入れますよと。でそれをムーブメントに入れて、アートフォースして、力として入力を行いますよという感じですね。で、現在の状況としては、これを実行すると、こんな感じで回りますよと。ね。で、横方向にもこんな感じで。で、落ちていくと。はい。こんな感じです。のところまでできています。はい。じゃあ次ですね。これはできましたよと。ちょっと待ってくださいね。どっから入れたっけ？ベクトルね。ベクトル。ごめん。マイク触っちゃった。ごめんなさい。で、ムーメバーティカル。ウニテさん。ウニ定食みたいな感じで、ウニテ。ウニ食いて。はいはい。まあできますよと。
good.
Good.
Let's test what we
Good. よし。はいはい。 できましたよ。はいはい。ね、なんか言いたいことあんの？次なんか言いたいことあんのこれ。
And create a tool that'll give us control over the speed of the ball. We need to multiply our movement by some value. We could simply enter that value here in our script, but if we ever needed to make any tweaks or changes, we would have to return to our scripting editor and change the value in the script and then recompile. This takes time. The solution is to create a public variable in our script. Let's create a public float called speed. By creating it,
そうね。パブリック変数の、フロート。あれ、フロート合ってるよ、スペル。合ってるよね。なんか文字の色が変わんねえな。スピードと。最近Python 触ってたんで、セミコロン忘れそうになるんですよね。
a public variable in our script, this variable will show up in the inspector as an editable
Python の弊害。
When we use a public variable, we can make all of our changes in the editor. We then multiply movement by speed. We now have control over our movement value from inside the editor. Let's save these changes and return to Unity. When we return to the editor, we can see our player controller script now has a speed property.
から戻ると、ちょっとこっちが、あれ表示されない。あれウニテイちゃん来た。ウニテイちゃんの中を見ると、スピードっていう値。あれちょっと待ってくださいね。こっち、なんでこれ、カタカナになってんの？どうなってんのこれ。いや、確かに日本語化のモッドというかデータを入れてるんですよ。なんでここまで変数名までカタカナになってんだけど。どういうこと？なんだろう、自動翻訳機能でもついてるのかな。まあいいや。よくないや。ちょっとこれが本当に対応してるかですよね。対応してるのこれ。スピード2に変えてみましょうか。よいしょ。対応してる。何あれ何あれマジでなんだろう。なんか、よく使う名前的なものにはこういうものをつけるみたいなやつが入ってるのかな。なんか代表的なものの名前ないですかね。フロート、ポジションとか。できる。できるこれ。できるこれ。すごい。すごいけど、いらない機能。いらないと言っちゃダメですね。そんな機能あるんだ。すげえ。知らんかった。頑張ってるね。まあいいや。次行きましょう、次。
Let's set this property to 100.
なるほどね。それはいい考えだ。で、それと、前へ移します。飛んでったね。ちょっと待って。左、右、前、後ろ、A、B。どっか飛んでっちゃいましたね。どっか飛んでっちゃった。止まった。はい。早すぎるよ。ヘイブラザー早すぎるぜ。
Now, enter play mode. Whoa, way too fast.
But
changes are fast too. Exit play mode and change the value to 10.
よし。10ね。やっぱり兄貴も早すぎるって言ってたね。俺もそう思うよ、兄貴。おう。今度は、おう。あ、なんかいい感じの、いい感じの、で、次行きましょう。
Hit play.
Yes, thank you very much. はい。次行きましょう。あ、ここに書いてありますね。マーク。じゃあ、continue to next step. Next step. Yeah. はい、次。Moving the camera. あ、カメラの位置ですね。
The camera doesn't move, and from its current position, cannot see very much. We need to tie the camera to the player game object. First, let's set the position of the camera. Let's lift it up by 10 units and tilt it down by about 45 degrees. Next, let's make the camera
上に10移動して、カメラ。上に10。上に10。回転45度。とか飛んでったけど。ちょっと待って、俺間違って。リセット。T ブラザーどこの値を動かした
child of the player game object. This degrees game object. Lift it up by 10 units and
あ、Y 動かしてるよね。Y 動かしてる。
tilt it down by about 45 degrees.
45度。あ、X だよ。困るぜ。よし。
Next, let's
これちゃいます。
make the camera a child of the player game object.
ピアノを子にします。これお前の子だったんだ。よし。
This is a typical third-person setup. With the camera as a child of the player, when we move the player's position, the camera moves with it. When the player rotates, the camera rotates as well. Let's look at this from a position where we can see both the player and the camera game object. Move the player. Rotate the player. The child camera moves with it. Now let's reset the player and test.
Yes.
We enter play mode, hold down the up arrow to move.
これは
Whoa, what's
失礼し
happening
ま
here?
す。気持ち悪くなるんで。
Okay, well, as the camera is a child of the player's
このトラッ
sphere,
プは覚えてる。
even though the camera is not moving at all relative to the player's game object, the player game object is rotating like crazy. So the camera's point of view rotates with it. Let's exit play mode. Unlike a normal third-person game, our player game object is rotating on all three axes, not just one. In a typical third-person setup, the camera, as a child of the player game object, will always be in a position relative to its immediate parent.
そうね。
And this position will be the parent's position in the game, modified or offset by any values in the child's transform. We can't have the camera as a child of the player, so let's detach it.
さよならパパ。
Our offset value will be the difference between the player game object and the camera.
よいしょ。
Now we need to associate the camera with the player game object, not as a child,
こ
but
れにす
with
る
a
ので
script.
スクリプトを使います。あ
Using the Add Component
あ。
button,
Add
choose
component,
New
new
Script.
Yes.
We are writing in C#,
あ、止められなかった。
and name
カ
the
メラのや
script
つカメラコントローラー。カメラコントローラー。カメラ。違うね。英語ができない。英語わかんない。 ってて。合ってるやん。もうやめてや。やめてな。やめてや。スクリプトを編集しますと。そうね。まあ、とりあえず。よいしょっと。次に、ボイド。あ、なんだろう、あれかな。もしかして、ユニティってこれかな。
Camera controller.
私の書き方、これなんだけど。おっと、スクリプトの場所間違えてるぜ。移動するぜ。はい、私の書き方、いつもこれなんだけど、ユニティの公式はこれなのか。
And then click on Create and Add, or simply hit the Return or Enter key to confirm our selection. We should note, this way of creating a script will create that script asset on the root or top level of our project view.
あ、そうね。
File Camera Controller in the Scripts folder and open it for editing. We need two variables here. A public game object reference to the player.
あ、そっか。まずね。パブリック。ゲームオブジェクト。プレイヤー。まあそうね。プレイヤーの。プレイヤーっていうのはもう丸々、これの名前でいいのか
な。And a private vector3 to hold our offset value.
そして、プライベート。V3 というベクター3の、オフセット。オフセっていう。
Offset is private because we can set that value here in the script. For our offset value, we will take the current transform position of the camera and subtract the transform position of the player to find the difference between the two. So in Start, we can make...
ああ、そっか。スタート。そうだか。そうだよね。これ必要だよね。スタート時にオフセットの値を取得しなきゃいけないけど。
Offset equal to our transform position minus the player's transform position.
ちょっと待ってね。トランスフォームポジションマイナスプレイヤーのポジショントランスフォームポジションベクターっていうのは位置をまあ3つの値を取得するやつで、トランスフォームポジションマイナストランスフォームポジションっていうのはつまるところこのカメラのポジションを持ってきたわけですね。これここの位置を持ってきます。でここからプレイヤーの位置を引きます。
And then every frame, we set our transform position to our player's transform position plus the offset.
なるほどね。相対位置関係を取得して、トランスフォーポジションのポジションに オフセットを足すことによって、おっと。位置を割り出すことができると。なるほどね。
This means, as we move our player with the controls on the keyboard, that each frame, before displaying what the camera can see, the camera is moved into a new position aligned with the player object, just as if it were a child of that object if it were not rolling around the game board. However, update is not the best place for this code. It is true that update runs every frame, and in update, each frame we can track the position of the player's game object and set the position of the camera. However, for follow cameras, procedural animation, and gathering last known states, it's best to use late update. Late update runs every frame, just like update. But it is guaranteed to run after all items have been processed in
update. 一番最後に実行されるアップデート分ってことですね。
So, when we set the position of the camera, we know absolutely that the player has moved for that frame.
頭いいっすね。
So let's test this. Let's save our script and return to Unity.
さあ、やってみましょう。よいしょ。おお、追跡してねえじゃねえか、バカ野郎。騙したな。てめえ。騙されてしまいました。あ、はいはい。こいつがなんかあれだね。よし、できた。こうしなきゃいけないわけですね。OK ハグ、OK ハグ。行ってこい、宇宙の彼方へ。はい、OK です。できたぜ。
Game object rotating.
なるほど。あそこのプレイヤー、ここね。ここのオブジェクト、プレイヤーっていうので別に、これがそのままあそこの名前になるわけではなくて、引数としてここで指定しなきゃいけないっていうことですね。プレイヤーいたらちょっと微妙だよね、これ。変数名が、日本語訳されちゃうと、こっちとこっちで差異が出てきちゃうんで、ちょっと日本語化のモッドはちょっと外した方がいいかもしれないですね。もしくは、ここが一般的な単語じゃなくすか。どっちかですね。Unity をするときは英語版にしましょう。これでいきます。はい。
So let's set up our play field.
ちょっと待ってね。これ消さないと。
The play field for our game will be very simple. We will place walls around the edges to keep our player game object from falling off, and we will create and place a set of collectible objects for our player to pick up. First, let's create a new game object and rename it walls.
Oh, walls.
This will be an organizing parent game object for our wall objects. Let's look at the organization of our hierarchy. Organization in our projects and our hierarchy are very important. We need to understand that organization at a glance. We organize our projects using folders or directories created by our operating system. We add these to our project using the Project View's Create menu. We organize our hierarchies by using game objects. In our scene, game objects can hold other game objects. Don't be afraid to use an empty game object as a directory or folder in the hierarchy. Reset.
わかんない。理解できない。よし。ちょっともう一度聞こう。もう壁を設定しますよと。 ごめんなさいね、ちょっと
game
頭悪くて。
object and rename it walls. This will be an and we will create and place a set of collectible objects for our player to pick up. First, let's create a new game object and rename it walls.
ゲームオブジェクトを作成していってゲームオブジェクトって何を選択する？
First, let's create a new game object and rename it.
ゲームオブジェクトっていうオブジェクトがあるってことか。あ、これね。へへ。なるほどね。
Walls. This will be an organizing parent game.
Walls. Yes.
Object for our wall objects.
親のゲームオブジェクト。
Let's look at the organization of our hierarchy. Organization in our projects and our hierarchy are very important. We need to understand that organization at a glance. We organize our projects using folders or directories created by our operating system. We add these to our project using the Project View's Create menu. We organize our hierarchies by using game objects. In our scene, game objects can hold other game objects. Don't be afraid to use an empty game object as a directory or folder in the hierarchy. Reset this game object to origin, and this step is important. We want the transforms of all of our container game objects to be at origin before we use them. Now we will build our walls. Let's start by creating a new cube to be our first wall. Rename this West Wall.
Cube. West Wall. Yes.
Reset this game object to origin. Now parent West Wall to our Walls game object.
で、これをリセットして、これを Walls のここにする。
Let's focus our scene view camera to our wall object. We can do this by typing the F key while the cursor is over the scene view, or by
F
selecting Edit, typing the F key while the cursor is over
カーソルをシーンレビューに合わせて。ああ、なるほどね。OK。
the scene view, or by selecting Edit, frame selected.
OK. I know.
We need to change the size of the cube to fit one side of our play area. Change the cube's transform scale of X, Y, and Z to 0.5.
OK。任せろ。ウエストってことは、ウエストは、go away 西か。よし。西ってことは、横に伸びちゃダメなんだよね。Y ってどっちだっけ？ Y やってみる。違いました。すいません。伸びろ。如意棒。Yes。兄貴できました。
For thin?
全然違え。厚さ 0.5、高さ2。厚さ 0.5？幅 20.5。長くね
2 for tall and 20.5 for long. Now we can simply push the wall into place using the Translate tool, or we could
よし、こんなもんでいいだろう。やっぱ長くね？ちょっと待ってくださいね。こうした方がよくね。ごめんなさいね。ちょっと待ってね。まあ、こんなもんで。まあ。隙間ある。隙間ありますね。これ、こういうのときつくね、これ。よし、来た。よし、来た。次。
We could enter a value into the transform component. In this case, we can set the transform's position x value.
兄貴、なんか兄貴。こう。よし。よし。大丈夫これ。ちょっと待って、プレーンの大きさ違う？明らかに違う気がする。
Value to -10. This places the wall neatly to the edge of our play area.
$3にしとこう。そしたらバレねえだろ。よし。3だとバレた。ちっちゃ。2だとちっちゃい。3だとでかい。2.5 だとちっちゃい。2.7 だとちっちゃい。2.9 だとちょうどいいぐらい。いや、ちょっとオーバーする。いいよ。いいよ。あれだよ。あれだよ。そのうち、あれだよ。うん。そのうちなんか解決策を持った人が登場してくれるから。今はこれで。よし。大体やってる。よし。次だ。
To create the next wall, we could start with another new cube, but then we'd have to rescale this new cube before we placed it. Our current west wall is already the perfect size. So, let's duplicate the west wall game.
なるほどね。それはいい考えだ。いいよ。ウエストフォーのハンダは、イーストウエストの判定はイースト？よし。よし。
Game object. Let's rename it East Wall.
よし。
To place the wall, simply remove the negative sign and it pops into place on the east side of our game area.
OK。 これやっぱりおかしくね。あ、そうだよね。あ、ウォール自体のあれか。これがあれなんですよね。こういう感じで、初期位置を持ってるんで、これからずれてたから、おかしなことになったんだよ。ああ、よかった。危ねえとこだったぜ。
area. Now let's duplicate the east wall and call it north wall.
North wall. North. 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 North wall. ひどい話だぜ。回転させますと。どっち方向かちょっとわかんないんで、ちょっとこれじゃないですね。あ、これでもないな。え
Reset the X position so the north wall is in the center of the play area. We now have two choices. We can rotate the wall by 90 degrees, or, as this is a cuboid,
ダメだ。位置をリセットってどうやってやるんだ。これか。リセットポジション。はいはいはい。
we can rescale the wall to 20.5 in the X and 0.5
あ、
in
そういうふうにやるね。よし。で、あとは、これを複製して、サースウォールにして、1をマイナス10にしてあげれば、完成と。で、あとはこれを、やりごこんな感じで、はいはい。まあ、初歩的な、ボールができましたよと。よし。
Z.
よーし。NEXT。
Next, let's create our collectible objects. Create a new cube and rename it Pickup.
キューブでピックアップ。
Reset the pickup's transform to origin. Focus
リセットポジション。
the scene view camera on the pickup object. The player game object is in the way.
そうね。
Let's select the
Design.
player game object and deselect the checkbox in front of the name field. This is the game object's active checkbox. Deselecting it will deactivate the game object in the scene.
チェックボックスになってるんですけど、これは目玉マークになってますね。
This will give us a clear working space for our new pickup object.
はいはいはい。
The cube is buried in the plane, just like our player's sphere was when we started this project. The cube is also a regular shape, 1 by 1 by 1. So let's lift it up by half a unit, and we know it's resting on the plane.
ちょっと待って、違う。ちょっと待って、違う。上に 0.5 を出しますと。ああ。いや、こんにちは。
This cube will be our pickup object. To be effective, it must attract the attention of the player. So let's make the cube more attractive. We will start by making it smaller. This will also give it the effect of floating above the play area. Both will help identify this object as special. Not enough, however. Let's tilt it over. 45, 45, 45 in as special. The effect of... We will start by making it smaller. This will also give it the effect of floating above the play area. To do this, we...
45、45、45。あ。なんだこれは。かわいいじゃないか。確かに特別感が出るね。気まずいか。よし。こっち真っ暗。
We need a script. With the pickup object selected, use the Add Component button in the inspector. Create a new script called Rotator.
Rotator.
Create a new script called
Rotator. Rotator. これ相変わらず、この中に突っ込むと。はいはい。
Rotator. Click Create and Add to confirm. Organize the script by placing it in the Scripts folder and open it for editing. We want the cube to spin, and we want to do it with this script. Let's remove the sample code we don't need. We will not be using forces, so we can use update rather than fixed update. We have already set the transform rotation in the transform component to 45, 45, 45 for the X, Y, and Z axes. But these values don't change by themselves. We want to change these values every frame. To make the cube spin, we don't want to set the transform rotation, but we want to rotate the transform. Next, type transform inside update. Select it and hold down the Control key on the PC or the Command key on the Mac and type single quote. Again, this brings up the page with the search term transform. Select transform. This brings up the transform page in the documentation. There are two main ways to affect the transform. These are translate and rotate. Translate moves the game object by its transform. Rotate rotates the game object by its transform. We will use rotate. So let's click on the link, and this brings up the page for transform rotate. Note again the two signatures and the two possible overrides, one using a vector 3 and the other using 3 float values for X, Y, and Z. Both overrides have the optional parameter space, which we will leave at default for this lesson. Again, we will choose the most simple form that only uses the vector 3 for direction. Let's return to our code. After transform, and make sure transform is written to begin with a lowercase t, write rotate. New, vector 3, 15, 30, 45. Now this action also needs to be smooth and frame rate independent, so we need to multiply the vector 3 value by time.delta time. Save this script and return to Unity. Test by entering play mode, and our pickup object rotates.
あ、この人か。で、セミコン、また忘れた。どういうことだ？ローテート。どういうことだ？ちょっと見てみよう。ああ、それぞれの方向に回転してるんですね。3方向すべてに。デルタタイム。初期の値とは関係なしにこう回転してるのかなっていう感じがしましたけど。どうなんですかね。これに時間経過をかけてるわけですよね。
So we need to multiply the vector 3 value by time.delta time. Save this script and return to Unity. Let's return to our code. After transform, and make sure transform is written to begin with a lowercase t, write rotate. New, vector 3, 15, 30, 45. Now this action also needs to be smooth and frame rate independent, so we need to multiply the vector 3 value.
これを消した場合、どうなりますか？これ回転しないと思うんだよね。多分するわ。
Value by time.delta time. Save this script and return to you.
タイム、デルタタイムどういう意味だ？ちょっと調べましょう。Unityタイム、デルタタイム。時間制御か。最後のフレームを完了するのに用意した時間100秒。フレームとは処理して画面を描写するまでの一高まりで頭にってこと。フレーム。すいません。つまり、経過時間をステップすることができます。通り、処理結果やフレームが出てますので、一定ではありません。なるほどね。わかんないけど、なるほどね。まあ、ゆっくりにするってことでいいのかな。アプ これただのアップデートの場合、マイフレーム更新を行うんだけれども、デルタタイムをすることによって、フレームを、遅らせることができると。はいはい。あ、こういうのは知ってる。こういうのはあるね。ははははは。合計1以上の時ですね、これは。これなんで。なるほど、なるほど、なるほど。で、多少、ほんとコンマ何秒ずれるけど、その気にしねえみたいなレベルですね。はいはい。なるほどね。
Unity. Test by entering play mode, and our pickup object rotates.
回転しましたね。はい。
Let's exit play mode. Okay, we have the start of a working pickup object.
Yes.
Next, we want to place these around the game area. But before we do this, we need to do one important step. We need to make our pickup object into a prefab. So remember, a prefab is an asset that contains a template or blueprint of a game object or game object family. We create a prefab from an existing game object or game object family, and once created, we can use this prefab in any scene in our current project. With the prefab of our pickup object, we will be able to make changes to a single instance in our scene or to the prefab asset itself, and all of the pickup objects in our game will be updated with those changes. So, first, let's create a folder to hold our prefabs.
Okay.
We want this folder on our root or top level of our project. So,
ルートに置きます。
select the project view and make sure that no other item or directory is highlighted. and then choose Create Folder. Rename this folder Prefabs.
Prefabs. Prefabs. よ。はい、Prefabs.
Now drag the pickup game object from our hierarchy and place it into our prefabs folder. When we drag an item from our hierarchy into our project view, we create a new prefab asset containing a template or blueprint of our game object or game object family.
ちょっと待って。
Template folder. Create folder. Rename this folder prefabs. Now drag the pickup game object from our hierarchy and place it into our...
そうやって持ってくるね。これを押す。本当にそれだけでなるんだ。
Prefabs folder. When we drag an item from our hierarchy into our project view, we create a new prefab asset containing a template or blueprint of our game object or game object family. Before we spread our collectibles around the game area, we should create a new game object to hold our pickups and to help organize our hierarchy. Let's create a new game object and call it Pickups. Check to make sure this parent game object is at origin and drag our pickup game object into it. Now we want folder. When we drag an item from our hierarchy into our project view, we create a new prefab asset containing a template or blueprint of our game object or game object family. Before we spread our collectibles around the game area, we should create a new game object to hold our pickups and to help organize our hierarchy. Let's create a new game object and call it Pickups. Check to make sure this parent game object is at origin and drag our pickup game object in.
逆だわ。よいしょ。これがピックアップスにして、この中に入れますと。
Into it. Now we want to spread a number of these pickup objects around the play area. First, make sure we have the pickup game object selected, not the parent. Now, let's move into a top-down view by clicking on the gizmo in the upper right of our scene view.
Gizmo.
Let's back out a little so we can see the entire game area. Grab the pickup game object, and it doesn't move in the scene the way we want it to. Note how the cube is moving in relation to its gizmo, which is tilted over. What we are seeing is the game object moving in local mode. We really want to move the pickup game object aligned with the ground. Change the editor to global mode. Now see how the orientation of the gizmo changes? Seeing is the game object moving in local mode. We really want to move the pickup game object aligned with the ground. Change the editor to global mode.
どっから選んだ? フローバーを。フローバーを。これ。あ、できたできた。
Now see how the orientation of the gizmo changes? And now we can drag our game object around relative to the world's global
あ、できまし
axes.
たね。はい。
So let's lay down a few of these in the game area. Take our first pickup object and place it into the game area, someplace convenient. I'm going to place mine at the top. With the game object selected, duplicate it. This can be done either by selecting Edit, Duplicate, or by using the hotkey combination. This is Command D on the Mac or Control D on the PC. Now we place
コントロール D。お、できた。コントロール D。おー。おー。よし。
place the second instance of the prefab. Using the hotkeys, we will create a few more, placing them around the play area. Note that I'm moving parallel to the ground or the XZ plane by selecting the XZ plane at the center of the gizmo. Okay, that's 12. Let's hit play and test.
Test. プレイヤー動かねえ。微動だですね。表示されてねえからかな。あ、置いた置いた。ぶつかっちゃうね、今回は。いいよ。はい。まあ、こんなもんで。
Excellent. These pickup prefabs are working great. The only thing that I want them to do now is stand out more against the background walls and player game object. Let's change their color. To do this, we need another material. To make things easy, we can simply select our existing material and duplicate it. Let's rename this new material.
まずはね、マテリアルをコピーして。あれ？複製ができない。あれ？あれ？マテリアルを作って、クリア用のアイテムといえば黄色だろう。ということで、黄色にして、これを、 ダメだわ。わかんねえわ。
Material pickup. With the materials selected in the project view, let's change the albedo color property to yellow. Now, we can change the color of the prefab by changing the prefab's material. We can do this in two ways. We can change the material on just one instantiated prefab. If we do this, we must remember to use the Apply button to apply those changes to the
一つ変えれば全部変わるんですかね。変わんねえじゃねえか。
prefab assets. We can change the material on just one instantiated prefab. If we do this, we must remember to use the Apply button.
わからん。んなくなってる？ここら辺にあったよね。おのれ。
Button to apply those changes to the prefab asset. Otherwise, we will only change the material on this single instance. The other way, which is perhaps more simple, is to simply change the material on the prefab asset directly.
あ、なるほどね。そっちの方が楽ですね。はい。いいよ。移動できねえ。移動が、これ移動したもんな。消えた。どこ行った？あ、できたできた。なるほどね。これならできますね。
Let's hit play and test. There, that looks better. In the next assignment, we will learn how to pick them up and count them.
順調だね。
We want to be able to pick up our collectible game objects when our player game object collides with them. To do this, we need to detect our collisions between the player game object and the pickup game objects.
うんうんうん。
We will need to have these collisions trigger a new behavior, and we'll need to test these collisions to make sure we are picking up the correct objects. The pickup objects, the player's sphere, the ground plane, and the walls all have colliders that inform us about collisions. If we didn't test our collisions to find out which objects we've collided with, we could collect the wrong objects. We could collect the floor or the walls. As a matter of fact, if we didn't test our collisions, on the very first frame of the game, we would come in contact with the ground plane, and we would collect the ground plane, and then we would fall into the void of the scene space, and the game would essentially be over. First, we don't need our player to remain inactive, so let's tick the active checkbox and bring back our player.
そうね。
Next, let's select the player controller script and open it for editing. Just a
プレイヤーのね。
note, we could edit this script regardless of whether the game object is active or not. Now that we have the script open, what code are we going to write? We could write collider and then search the documentation using the hotkey combination. But there is a different way that we could do this as well. Let's return to Unity and look at the details of our player game object. What we are interested in here is the sphere collider component.
Mm, これか。
In the header of each component on the left is the component's turn-down arrow, the icon, the enabled checkbox if it's available, and the type of the component. On the right is the context-sensitive gear gizmo, and an icon of a little book with a question mark. Now this is what we need. This is the quick link to the component reference. If we select this icon, we are taken not to the scripting reference, but to the component reference. We would read this document to find out more about how to use this component in the context of the editor. We, however, want to find out how to script to this component's class. To do this, we simply switch to scripting, and we are taken to the scripting reference for the sphere collider. We want to detect and test our collisions. For this project, we are going to use onTriggerEnter. Just imagine if we were, say, a daring plumber, and we jumped up to collect a perfect arc of coins, and bounced off the very first one as we collected it and fell back to the ground. Not very elegant. This code will give us the ability to detect the contact between our player game object and our pickup game objects without actually creating a physical collision. The code example, however, is not exactly what we're looking for. But that's okay. We can change that. First, let's copy the code. And then let's return to our scripting application. Now that we're back in scripting, let's paste the code. As we have copied this code from a web...
多分これはこれですね。オントリガーエディター。ほい。あ、基本的にコピーはしないんで。あ、エディターじゃなくてエンターだ。はい。Destroy.
Web page, let's correct the indents. In this case, I'm going to make sure the indents are tabs and that all of the tabs are correctly aligned. Next, let's look at this code. We are using the function onTriggerEnter. OnTriggerEnter will be called by Unity when our player game object first touches a trigger collider. We are given as an argument a reference to the trigger collider that
な
we
るほどね。ということは今この状態で、実行した場合、床が抜けると。やってみましょう。ポチッ。そんなことない。あれダメか。ダメでしょうか。
have touched.
違った。
This is the collider called Other. This reference gives us a way to get a hold of the colliders that we touch. With this code, when we touch another trigger collider, we will destroy the game object that the trigger collider is attached to through the reference other.gameObject. By destroying that game object, the game object, all of its components, and
おかしいなぁ。絶対にそうだと思ってないよな。消えねえな。デストロイされると思ったんだけどな。
and all of its children and their components are removed from the scene.
ね、進化される
For
さ
the
れます。
sake of example, in this assignment, we won't destroy the other game object, we will deactivate it. Just like we deactivated the player object when we were creating our pickup objects. First, let's remove the destroy other game object code from the function. But let's paste it down below our script as a palette to work with. How will we deactivate our pickup objects? Well, what clues do we have? We can address the other collider's game object through other.gameObject. We can see this here in the sample code.
そうね。
And we want to test the other game object. And if it's a pickup object, we want to deactivate that game object. So let's look up gameObject with our hotkey combination and see what we can find. Now we have the page on gameObject. There are a few important items here that we want. They are tag. Tag allows us to identify a game object by comparing the tag value to a string.
ピックアップ
And setActive. This is how we activate or deactivate a game object through code. The last item we need to know about is compareTag. CompareTag allows us to efficiently compare the tag of any game object to a string value. Let's open up these three items, each in their own tab. Tag allows us to identify a game object by a tag value. We must declare our tags in the Tags and Layers panel before using them. It is possible to test a tag against a string value directly with code like if gameObject.tag is the same as some string value. But there is a more efficient built-in way to do this, and that is compareTag. With compareTag, we can efficiently compare the tag of any game object with a string value. Let's copy the sample code and paste it into our working palette. Now, gameObject setActive. This is how we activate or deactivate a game object. This is the code equivalent of clicking the active checkbox next to the name field in the inspector. In our case, just like the code snippet, we will call gameObject setActive false to deactivate our pickup game objects. Let's copy this code and, returning to our script editor, paste it into our palette as well. I feel we have enough pieces to write our code. So let's write if other.gameObject.compareTag with the string value of pickup. And we will have to declare this tag in Unity later. Other.gameObject.setActive false. Now this code will be called every time we touch a trigger collider. We are given a reference to the collider we touch. We test its tag, and if the tag is the same as the string value pickup, we will take the other game object and
ちょっと待って、これピックアップって、名前、 名前があれなんだけど。こんな感じでやってみましょうか。オールコンパイルエラーフィクストビーなんちゃら。これね。はい、おーいえー。おーいえー。おーいえー。おいえ全然ダメなんだけど。これプレイヤーだよな。プレイヤーコントローラー。合ってんだ。合ってんな。なんでや。
We will call setActive false, which will deactivate that game object. Now, we don't need this code we've been saving anymore, and keeping it will only confuse the compiler, so we can delete it.
それな。知ってる。
Let's save this script and return to Unity and check for errors. The first thing we need to do is set up the tag value for the pickup objects. Select the prefab asset for the pickup object. When we look at the tag list, we don't see any tag called pickup, so we need to add one. Select Add Tag.
なるほどね。タグをつける必要があると。じゃあ、別にあれでもよかったわけですね。ピカチュウ。こいつは最強か？ピカタグになってますよね。こいつはなんだ？最強か？
This brings up the Tags and Layers panel. Here we can customize tags and layers. Note that this tags list is empty. To create a new custom tag, select the plus button to add a new row to the tags list. In the new empty element, in our case tag 0, type pickup. And this is case sensitive and needs to be exactly the same string that we have in our script. If in doubt, we can copy and paste this string to get the exact value. When we look back at the prefab asset, note that the asset is still untagged. By selecting Add Tag, we changed our focus from the prefab asset to the Tag Manager. And in the Tag Manager, we created our tag. Now we need to apply that tag to the prefab asset. Select the Tag drop-down again, and see how we now have Pickup in the list. Select this tag from the list, and the asset is now tagged Pickup. And, with the power of prefabs, all of the instances are now tagged Pickup as well. Now let's test our game. Save the scene and enter play mode. Okay. Our tag is set to Pickup, but we are still bouncing off the Pickup cubes just like we are bouncing off the walls. So let's exit play mode. Before we discuss why we are bouncing off the Pickup cubes rather than picking them up, we need to have a brief discussion about Unity's physics system. I'm going to enter play mode for this discussion. Let's look at one of our cubes and our player. As an aside, we can select 2 or more game objects at the same time and inspect them all. We do this by holding down the Command key on the Mac or the Control key on the PC and selecting the game objects. When we select multiple game objects, note how the inspector changes to show the common components and property values of the selected game objects. The inspector also allows for multi-object editing. Using multi-object editing, I'm going to disable the mesh renderer on both the player sphere and the selected cube with a single click. This leaves us with the two green outlines of the collider volumes for these two objects. How do collisions work in Unity's physics engine? The physics engine does not allow two collider volumes to overlap. When the physics engine detects that any two or more colliders will overlap that frame, the physics engine will look at the objects and analyze their speed and rotation and shape, and calculate a collision. One of the major factors in this calculation is whether the colliders are static or dynamic. Static colliders are usually non-moving parts of your scene, like the walls, the floor, or the fountain in the courtyard. Dynamic colliders are things that move, like the player's sphere or a car. When calculating a collision, the static geometry will not be affected by the collision, but the dynamic objects will be. In our case, the player's sphere is dynamic or moving geometry, and it is bouncing off the static geometry of the cubes, just as it bounces off the static geometry of the walls. The physics engine can, however, allow the penetration or overlap of collider volumes. When it does this, the physics engine still calculates the collider volumes and keeps track of the collider overlap, but it doesn't physically act on the overlapping objects. It doesn't cause a collision. We do this by making our colliders into triggers or trigger colliders. When we make our colliders into a trigger or trigger collider, we can detect the contact with that trigger through the onTrigger event messages. When a collider is a trigger, you can do clever things like place a trigger in the middle of a doorway in, say, an adventure game. And when the player enters the trigger, the minimap updates and a message plays, "You have discovered this room." Or every time your player walks around that corner, spiders drop from the ceiling, because the player has walked through a trigger. For more information on onCollision and onTrigger messages, see the lessons linked below. We are using onTrigger enter in our code rather than onCollision enter, so we need to change our collider volumes into trigger volumes. To do this, we must be out of play mode. Let's select the prefab asset and look at the box collider component. Here we select is trigger, and again, the power of prefabs, all of our
チェックを入れると。
pickup objects are now using trigger colliders.
ほうほうほう。
Let's save our scene, enter play mode, and
もう一回やってみようと。なるほどね。トリガーになってないといけないってことね。ふぅ。あ、できるできる。おー、できるできる。おー。あれ。OK です。あざっす。
test. And as our player enters the trigger, we pick up the objects.
うまい
Excellent.
な。あ、
Let's exit
おい
play
おい、う
mode.
まいな。よし。
Everything looks great. We only have one issue. We have made one small mistake. And this is related to how Unity optimizes its physics.
ほう。
As a performance optimization, Unity calculates all the volumes of all the static colliders in a scene and holds this information in a cache. This makes sense as static colliders shouldn't move, and this saves recalculating this information every frame. Where we have made our mistake is by rotating our cubes. Anytime we move, rotate, or scale a static collider, Unity will recalculate all the static colliders again and update the static collider cache. To recalculate the cache takes resources. We can move, rotate, or scale dynamic colliders as often as we want, and Unity won't recache any collider volumes. Unity expects us to move colliders. We simply need to indicate to Unity which colliders are dynamic before we move them. We do this by using the rigid body component. Any game object with a collider and a rigid body is considered dynamic. Any game object with a collider attached but no physics rigid body is expected to be static.
Oh.
Currently, our pickup game objects have a box collider, but no rigid body, so Unity is recalculating our static collider cache every frame. The solution is to add a rigid body to the pickup object.
グラブにリキッドボディを追加すると。リキッドボディ。
This will move the cubes from being static colliders to being dynamic colliders. Let's save and play. And our cubes fall through the floor. Gravity pulls them down. And as they are triggers, they don't collide with the floor. Let's exit play mode. If we look at the rigid body component, we could simply disable use gravity, which would prevent the cubes from being pulled downwards. This is only a partial solution, however. If we did this, even though our cubes would not respond to gravity, they would still respond to physics forces. There is a better solution, and that is to select is kinematic. When we do this, we set this rigid body component to be a kinematic rigid body. A kinematic rigid body will not react to physics forces, and it can be animated and moved by its transform. This is great for everything from objects with colliders, like elevators and moving platforms, to objects with triggers, like our collectibles, that need to be animated or moved by their transform. For more information on the rigid body and is kinematic, see the lessons linked below. Let's save our scene and enter play mode to test. Now our behavior is identical and performant. So, static colliders shouldn't move, like walls and floors. Dynamic colliders can move and have a rigid body attached. Standard rigid bodies are moved using physics forces. Kinematic rigid bodies are moved using their transform. In the next assignment, we will count our collectible objects and make a simple UI to display our score and messages.
Yes. 終了。次行こう。ああ、そうね。スコア表示は必要やね。これもしかしてもう終了？あ、もうほぼ終了ですね。
Counting, displaying text, and ending the game. We need a tool to store the value of our counted collectibles, and another tool to add to that value as we collect and count them. Let's add this tool to our player controller script. Select the player game object and open the player controller script for editing. Let's add a private variable to hold our count. This will be an int, as our count will be a whole number. We won't be collecting partial objects. And let
プライベートね。プライベートなアカウント。あ、イントのアカウントね。
Let's call it count. So, in our game, we will first start with a count of 0. Then we will need to increment our count value by 1 when we pick up a new object. First, we need to set our count value to 0. As this variable is private, we don't have any access to it in the inspector. This variable is only available for use within this script, and as such, we will need to set its starting value here in the script. There are several ways we can set the starting value of count, but in this assignment, we will do it in the start function. In start, set our count to be equal to 0. Next, we need to add to count when we pick up our collectible game objects. We will pick up our objects in onTriggerEnter if the other game object has the tag pickup. So this is where we add our counting code. After setting the other game object's active state to false, we add our new value of count is equal to our old value of count plus 1. There are other ways to add, count up or increment a value when coding for Unity, but this one is very easy to understand, and this is the one that we're going to use in this assignment. Save this script and return to Unity. Now we can store and increment our count, but we have no way of displaying it. It would also be good to display a message when the game is over. To display text in this assignment, we will be using Unity's UI toolset to display our text and values. First, let's create a new UI text element from the hierarchy's Create menu.
UI。あ、もう、テキスト。UI からテキストでいいんだな。
Let's look at what we've added to the hierarchy. We seem to have gotten more than we bargained for. We don't just have a UI text element, but we've also created a parent canvas element and an event systems game object. These are all required by the UI toolset. The single most important thing to know about these additional items is that all UI elements must be the child of a canvas to behave correctly. For more information on the UI tools, including the canvas and the event system, please see the information link below. Rename the text element CountText.
CountText.
So let's customize this element a bit. The default text is a bit dark. Let's make the text color white, so it's
white.
easier to see. The size and alignment are good. And let's add some placeholder text. Count text. We want our text to display in the upper left of the screen when the game is playing. We can see that the UI text is currently displaying in the center of the screen in the game view. This is because the text element is anchored to the center of its parent, which is, in this case, the canvas. It is worth noting that the transform component on UI elements is different from the other game objects in Unity. For UI elements, the standard transform has been replaced with the rect transform, which takes into account many specialized features necessary for a versatile UI system, including anchoring and positioning. For more information on the rect transform, please see the information link below. One of the easiest ways to move the count text element into the upper left is to anchor it to the upper left corner of the canvas, rather than to its center. To do this, open the Anchors and Presets menu by clicking on the button displaying the current anchor preset. When we re-anchor this text element, we also want to set the pivot and the position based on the new anchor. So we will hold down both the Shift and the Alt keys, and then select the upper left corner button. That's done it, it's up in the corner.
Shift と Alt を押しながら。なるほどね。
But now it looks budged up against the corner of the game view. Let's give it some space between the text and the edges of the screen, as we are anchored to the upper left corner of the canvas, and we've set our pivot to the upper left corner as well. The easiest way to give the text a little breathing room is to change the rect transform's pause X and pause Y values. 10 and minus 10 seems about right, with some room around it, yet it's still up and out of the way. So let's wire up the UI text element to display our count value. Start by opening the player controller script for editing. Before we can code anything related to any UI elements, we need to tell our script more about them. The details about the UI toolset are held in what's called a namespace. We need to use this namespace, just as we are using Unity Engine and System Collections. So, to do this, at the top of our script, write using unityengine.ui. With this in place, we can now write our code. First, create a new public text variable called countText to hold a reference to the UI text component on our UI text game object. We need to set the starting value of the UI text the details about the UI tool namespace, just as we are using Unity Engine and System Collections. So, to do this, at the top of our script, write using unityengine.ui. With this in place, we can now write our code. First, create a new public text variable called countText to hold
おい、テキストがねえぞ。マジで。テキストフィールドにしとくか。カウント、テキスト。
hold a reference to the UI text component on our UI text game object. We need to set the starting value of the UI text property. We can do this in Start as well. Write countText.text equals the string value of count :space plus count to string.
プラスできるんだ。おい、それに、カッコもいる。了解です。おや鼻が詰まってる。これじゃダメですと。アクセサリーにアクセスすればいいんだね。あ、このコンテキストは使用できません。ダメか。テキストフィールドじゃダメか。でもテキストないんだもんな。どうしたらいいかな。クラドンさんクラドンさん助けて。テキストってどうやってすんの。テキストエレメントで言ってたりしないかな。いけそうこれいける
string, and we need the parentheses. Now this line of code must be written after the line setting our count value. Count must have some value for us to set the text with. Now we also need to update this text property every time we pick up a new collectible. So in onTriggerEnter, after we increment our count value, let's write again countText.text equals count :space plus count to string. We've now written the same line of code twice in the same script. This is generally bad form. One way to make this a little more elegant is to create a function that does the work in one place, and we simply call this function every time we need it. Let's create a new function with void set count text, and then an empty set of parentheses and brackets. Now, let's move one instance of this line of code into the function by cutting and pasting it. And in its place, let's put a line of code simply calling the function. Finally, let's replace the other line with the function call as well. Excellent. Save and swap back to Unity. Now we can see our player controller screen. And in its place, let's put a line of code simply calling the function. Finally, let's replace the other line with the function call as well. Excellent. Save and swap back to Unity. Now we can see our player controller script has a new text property. We can associate a reference to our count text simply by dragging and dropping the count text game object into the slot.
Ah, やべえ。オブジェクト設定忘れた。これやっぱりテキスト存在するんじゃないの？存在しない？いや、ここに存在しないよりこっちが存在しているとか、そんなオチが。ダメだ。ダメだ。指定できねえ。どうしたらいいですかね。
Finally, let's replace the other line with the function called a reference to our count text or control.
Hmm. テキスト属性がなっちゃったな。テキストフィールドじゃダメって言われちゃったしな。テキストエレメントだと表示されねえしな。C#。型。今何になった？テキスト型がない。存在しない。ないよ、やっぱり。ないよ、やっぱり。やっぱりないよ。テキスト型なんてないよ。どうしたもんすかね。どうしましょう。誰か教えて。わかんねえ。ストリングとかでいけんじゃねえのって。その後これテキストになんねえのか。 違うもんね。テキストフィールド。当たりになりそうだけど、テキストがな。ね。テキストになってるなぁ。でもできねえんだよなぁ。あ、でも俺、ストリングテキスト。うーん。Unity の UI エレメンツの中のあれだよな。変数型だよな、多分。 ないもんな。違うっぽいか。UI エレメンツ。これはエディター拡張に間違えた。あ、違うっぽいなぁ。UI が出てこないんだよ。なんでだ ?Unity エンジン .UI。ねんだけど。エラー起こるんだけど。このままいけたりするのかな。やってみた。あ、でも、エラー起こらずに行く。あ、エラー起こらずに行くこれ。もしかしてだけど。来た。あ、来てる。マジかよ。つまり、この、今入ってるやつだと、今入ってるやつだと、Unity の、Unity UI のやつに対応してないみたいですね。今入ってるのが、C シャープのやつが入ってるんですけど、Unity のやつが入ってないんですよね。これ入れた方がいいのかな ?Unity。C シャープ。デバッカー for Unity じゃなくて。じゃなくて。VS コード。Unity でちょっと検索してみますか。コード拡張は。うん、これも入れとけって書いてあるね。じゃあ入れとくか。UI とかが抜けてると思わなかったな。 トか。入れてみましょう。はい。これで、動くようになったりしない。やっぱりないって言われちゃうんだよ。言われちゃいますね。他にそうなってる人いるかな。あ、なんか検索結果に出てくる。あバージョン 1.4。こっちのバージョンじゃなくて別のバージョン。Unity のウィンドウ。なんたらマネージメント。パッケージマネージャーこれか。どうやってアップグレードダウングレードするの？一旦消してみるか。ってことして。これで OK。ちょっと一旦再起動しますか。保存。ウニテ。 あ、消えてますね。よかったー。これで大丈夫。OK。
Excellent. Save and swap back to Unity. Now we can see our player controller script has a new text property. We can associate a reference to our count text simply by dragging and dropping the count text game object into the slot. Unity will find the text component on the game object and correctly associate the reference. Now let's save, enter play mode, and test. Aha! Not only do we collect these objects, but we count them now. Let's exit play mode. We need to display a message when we have collected all of the cubes. To do this, we will need another UI text element. Again, using the Hierarchies Create menu, make a new UI text element and rename it WinText.
WinText.
Note how this new UI text element is automatically added to our canvas. Again, as before, let's customize the values on the component. Let's color the text white so it is easier to see. Let's make the text a little larger. Let's try about 24. Lastly, let's adjust the alignment to center and middle. And again, let's add placeholder text. WinText. We want this text to display in the center of the game screen, but up a little so it doesn't cover the player game object. To do this, simply adjust the rect transform's pos y value, as by default, this UI text element is anchored to the center of the canvas. A value of about 75 feels good. Save the scene and swap back to the scripting editor. We need to add a reference to this UI text element. Create a new public text variable and call it WinText. Now, let's set the starting value for the UI text's text property. This is set to an empty string, or 2 double quote marks with no content. This text property will
まさか 1.2 でもダメだったとは。よで 1.3 なら大丈夫っていう情報があったんですけど、どうでしょう。ああ、できましたね。よかった。
start empty. Then in the setCountText function, let's write if count is greater than or equal to 12, which is the total number of objects we have in the game to collect, then our winText.text equals you win. Save this script and return to Unity. Again, on our player controller has a new UI text property. We can associate the component, again by dragging the winText game object into the slot. Save the scene and play.
プレイヤーのとこに設定するの忘れたぜ。よし。
So we're picking up our game objects. We're counting our collectibles. And we win! And as we can see, when we have collected 12 objects, we display the You Win text. In the next and last assignment of this series, we will build the game and deploy it using a standalone player.
素晴らしい。
Now that we've finished our game, we need to present it to our players. One of the greatest things about Unity is that once we have created our game, we can deploy it to many of the current platforms. For more detailed information on building and build targets, please see the lesson link below. Before we build our game, we should save our scene. To build our game, we must first open the Build Settings window. We can do this by selecting File, Build Settings, or by using the key combination of Shift plus Command or Control plus B. This brings up the Build Settings window. Our current build target is indicated by the Unity logo. The blue highlight indicates our focus and shows us, on the right-hand side, the build options for the currently selected platform. We want to build a standalone application. This is our current build target, PC, Mac, and Linux standalone. We do not need to change our build target. If we did want to change our build target, we can select the desired platform from the list and click the Switch Platforms button at the bottom of the window. Let's now return our build target to the standalone player. Once we have selected our new build target, we need to add the scenes we want to build to the Build Settings window. We can add the current scene by clicking the Add Current button, or we can drag and drop any scene from our project view into the field at the top of the Build Settings window. It's worth noting that we don't need to include every scene in our project. We only need to include the scenes we want in our game. It is also possible to perform a build with no scenes in the Build Settings window. If we do this, Unity will simply build our game using the current scene we have open for editing. Now we are ready to build our game. Let's return to the Build Settings window and click the Build button. This will bring up a dialog box asking us to choose a build location. I like to associate my build location with my project, so I will create a new folder inside my project called Builds. This folder must be placed only on the root of our project alongside the assets and library folders. With the build folder selected, let's name the build. And then click Save. Unity will now build the application. and save it to our builds folder. When building for the Mac, Unity builds a .app bundle, which contains all of the relevant data and files. When building for Windows, Unity builds a .exe file and a data folder which contains all of the necessary resources.
なるほど。Windows。さて。できた。実行。かっこいい。あ、完璧。あ、ゲームだね、これ。ゲームできてるね。この紙ゲーをちょっと最高の要因。この最高の紙ゲーをちょっとこの紙ゲーをスチームで1000円ぐらいで売り出すか。よいしょ。終了方法はこのゲームログアウトができない。なんだ、ソードアートオンラインがここから始まるのかな。さてと。いきます。さて、GM が出てくる前にゲームを終わらせたんで、知ることはないだろう。
And now we are running our game. And these assignments, we have learned how to create new game objects, write our own custom behaviors for them using simple scripting. We've seen how to use lights, cameras, colliders, triggers, rigid bodies. We can collect and count objects. Though this is a very simple example, it covers a large set of basic subjects important to understanding how learning about assignments and projects.
よし。コンプリート。よーし。これで、終了しました。いやー、長く険しい戦いでしたね。よし。それじゃあ、時間もちょうどいいんで、今日はここまでにしようと思います。明日は、さらに Unity をやっていくんですけれども、次何しようかね。基礎みたいなやつが終わったんで、次に行きたいと思います。次はもうちょっと難しいやつをやってみたいですね。探してみます。はい。それでは、今日は終わりにします。ありがとうございました。